Hi everybody, this is lesson 1 of module 2. We are on to our next module and this is the first lesson. Opposite quantities combine to make 0. So you've got your essential question. We are actually on page 7, so if you're still looking for the page number, page 7. How can we model addition on the number line? And what is the sum of a number and its opposite? So there are your essential questions. And let's talk real quick about what are some examples of negative numbers and positive numbers. Go ahead and write down some words that make you think of negative numbers and words that make you think of positive numbers. You can pause it. When you unpause it, you can add the ones that I'm about to write in. So here we go for negative numbers. The numbers are left of 0 on the number line. We hear words such as loss, drop, decrease. These are all meaning like negative or go down. In fact, let's go ahead and write that, go down. Below sea level. You might see questions that use the calendar year BC. We can withdraw money. And my favorite one to use for negative numbers is to owe money. We're going to think about owing. Okay, negative numbers look like -7, -8, so on and so forth. And negative numbers are opposite of positive numbers. Okay, and we're going to skip the middle. This is talking about what negative and positive numbers are together. So that doesn't actually mean 0. That's one logical thing, but it just means that, you know, negative and positive numbers both have something in common. So let's just put one thing down there. They're both on the number line. The reason 0 wouldn't make sense on a Venn diagram here is because 0 is actually neither negative nor is it positive, so it wouldn't be both. Okay, let's jump over to the positive numbers. They are to the right of 0 on the number line. We hear words like gain, increase, go up, above sea level. And then you're also going to have some story problems that have to do with the years that are considered AD, which like we're in right now, 2016. Okay, and then they do not have a sign. So they just look like 7, 8, so on and so forth. And positive numbers are opposite of negative numbers. Okay, and I know that you've learned, you know, positive and negative numbers before, so hopefully this feels like a review. Moving on to page 8, we're going to talk about which one would be positive and which one would be negative. If I'm counting up, that means what? I'm talking about, is it positive or negative? Positive. We just said that going up is positive, so then going down would be negative. So counting up, counting down. We're going to think of counting up as going to the right, and counting down, negative, we would be moving to the left. So where do you begin when locating a number on the number line? This is that special number. Hopefully you know it is the number 0. Okay, and we can write it like this or with a line through it so you know it's not the letter O, it's 0. Okay, so there you go. There's your little starting point right there. All right, what do you call the distance between a number and 0 on the number line? So what do we call that distance? You might not know this term. This could be a new term, but I want you to write it now. It is called the absolute value. And that just means how far is the number from 0. And that's it. That's literally all it means. Okay, what is the relationship between 7 and -7? 7 and -7. They are called, you might know this term from last year. They are called opposites. That was also in your essential question. We talked about it in the Venn diagram, so hopefully that is familiar to you. So they are called opposites, and if you go back up to your graph, we're going to do this real quick. If I want to go from 0 to positive 7, I have to move 7 places to the right. If I want to go from 0 to negative 7, I'm moving 7 places to the left. The thing about absolute value is that I moved the same distance. I moved 7 whether I went to the right or the left. So the absolute value is how far I went. It doesn't have to do with the direction. It's just saying what is the distance. So the interesting thing here is that 7 and negative 7 have the same absolute value of 7 because they each are 7 units from 0. So remember, absolute value is how far a number is from 0. Okay, not too bad. You did learn a new term, but hopefully this is not too overwhelming. We're just talking about the distance from 0 on a number line. And we know that they're called opposites. So two numbers that are the same distance from 0 are called opposites. Think of another one on the number line. I thought of negative 4 and positive 4. Those are the same distance from 0. They're called opposites, and they have the same absolute value because each one of them is 1, 2, 3, 4 away from 0. 1, 2, 3, 4. So I would have to move 4 places to get back to 0 or to get from 0 to the number. Okay, and we are already on to example 3. Using the integer game and the number line. I'll be explaining the integer game more in class, but for now, what I'm going to explain to you is if you're holding a deck of cards and you want to know what is the value of these cards. I like to think of this as money. That's what makes the most sense to me and in real life. So what you can do is you can think about, like, if I had $5, that would be the first one. Okay, so I have $5, and then I owe $5, or I spend $5. Then I spend $4 more, and then I get $8. So we're going to think about these in positives and negatives. Let's show how that would look on the number line. Positive 5 means move 5 places to the right. So we start at 0 and go 1, 2, 3, 4, 5. We went 5 places to the right. Okay, then we go 5 places to the left. So I'm going to draw this one up starting at where I left off. Okay, and I'm going to go 1, 2, 3, 4, 5. Are you surprised that we ended back at 0 because it was an opposite? Okay, so that one was to the left. Oh, it looks like we're going to the left again because it's another negative. So let's keep going. 1, 2, 3, 4 to the left. Okay, I'm at negative 4. And the last one says positive 8, so I want to move 8 places to the right. This is where you have to be very careful. You can even use your pencil here if you don't want to make a mistake and you want to be very careful with your lines. I'm going to do it above that because I know I'm going to be careful when I go from negative 4. I want to go to the right 8. So we start here and go 1, 2, 3, 4. That brings me to 0. I have to go 4 more, so we're at 5, 6, 7, 8. And where did we end up? Positive 4. Positive 4. You can put the positive sign in front or not. Usually we see it without it, so that's what it would look like. We ended up at positive 4. Okay, what card or combinations of card would you need to get back to 0? So I'm here. How do I get back to 0? What card would you need? I'll give you a hint. There's actually more than one answer here. So there's a couple ways you could write it. Here's what I'm going to say. I'm going to say negative 4 or a combination of cards that equals negative 4. Can you think of another combination that would help me move left 4? I would say negative 3 and negative 1. Or I could do negative 2 and negative 2, assuming that there's more than one negative 2 in the deck. Okay, so something that's going to help me move left 4 places. Okay, so that was your first actual example of adding with positive and negative numbers. So that's actually what this was. We were doing 5 plus -5 plus -4 plus 8. And we know that the final answer there was 4. Okay, let's move on to another example. We're going to do exercise 2. It's called the additive inverse. Okay, this one's going to help us really understand opposites and how they work together to get an answer. So first thing is, how far is 7 from 0 and in what direction? I want you to pause this and I want you to go ahead and answer all these problems. We'll call this one number 1, number 2, number 3. Go ahead and answer 1, 2, and 3 on your own. Unpause it when you are ready to see the answers. Okay. Okay, the first one, did you get 7 units to the right? To the right, because it was positive. Okay, what is the opposite of 7? Did you get -7? Hopefully. And then how far is -7 from 0 and in what direction? So your answer is going to look a lot like this one, except it should say 7 units to the left. 7 units to the left. Okay, thinking back to our previous one, how would you use the counting method up here? It's kind of like talking about the number line. How would we use that to represent the following? While playing the integer game, so you're pretending like you have a card that's a 7, and then a second card that's a -7. So here's what we would do. Just go on back up to where we were, and we start at 0, and it first says +7. So 1, 2, 3, 4, 5, 6, 7. That's +7. And then it says you'd select a -7. So we go left 7 from there. 1, 2, 3, 4, 5, 6, 7. And where did we end up? Right back at 0. Very good. Okay, so for that one, what did we do? We started at 0. We moved 7 to the right. Then 7 to the left. Okay, and then what does that tell us about 7 and -7? The sum. Underline that word sum. Sum. You know what operation that is. It is addition. Hopefully you said addition. You knew that a sum meant addition. So it's going to be addition, and there's going to be an answer. So what does it tell us about the sum of 7 and its opposite, -7? So what does that tell us? That it is 0. The sum is 0. Okay, so go ahead and look at the curved arrows that we drew for 7 and -7. What relationship exists between these two arrows that would support your claim of 7 and -7? Well, that question might be kind of confusing, so I'm just going to tell you it's basically saying, what can you tell about these two arrows? Like, what do they have in common that backs up what we're saying there, that 7 plus -7 is 0? And I think that it makes sense to say that the arrows have the same length or distance because they are both 7 away from 0. Okay, they are each 7 units long. So let's go ahead and add that so we know. They are each 7 units long. Okay, now what do you think? Do you think that that would hold true for the sum of any number and its opposite, or is that just special for the 7s? Yes, that's true for any set of opposites. Yes, let's go ahead and prove it though. Think of an opposite and write it down. I'm going to write down, let's see, my favorite number is 10. 10 plus the opposite of 10 is -10. The reason I like money is because this helps me think like, okay, I have $10 and then I owe someone $10, or maybe I spend $10. So basically, if I have a $10 bill and I spend a $10 bill, I'm left with 0. So that's an example of opposites. You can write something else besides 10 plus -10. You could even write it in the other order. You can do -10 plus 10. Okay, so what is additive inverse? Here's your definition. Additive inverse is the opposite of that number on the number line. Let's say the opposite of a given number on a number line. And we'll move that out of the way. Okay, and that's actually going to be it. But do not cross off page 10 or 11. Sorry, go to page 11 real quick, and I want you to write in class, and we're going to be doing this one in class, and then you're still responsible for the summary. You can do the summary now if you'd like. You can even do these ones now if you'd like. You don't need to learn anything more. This is kind of you on your own making up real world examples, but I want to be able to help you to make sure that your examples make sense. So let's go ahead and save this for in class, and you can do the summary now. And that is a wrap on lesson number 1. See you in class.